Okay, so let's look at what the platonic solids are. You can look on page 718 in your textbook to see those, and I'll also just Google it right now so we can see it.
So we made both of those in our shapes, didn't we?
Yeah, you were working on making these. But now you can see here, here's the dodecagon. It's made up of regular pentagons, and at this vertex, you've got 3 pentagons coming together, and each angle is 108 degrees, so it's 324 degrees total around that vertex, which makes sense because if it was a flat paper, it would be 360 around a point, but since it's a solid, it's folded in. So you just have to, in order to get a platonic solid with regular figures as the faces, you have to have less than 360 at each vertex. So here was 270 degrees at this vertex because you've got 90, 90, and 90. So that's less than 360. In the tetrahedron, there was 60, 60, and 60. So 180 degrees there. How about this one right here? We've got equilateral triangles all the way around that point. How many degrees are coming together to make this point on the icosahedron made of equilateral triangles?
180.
20 faces.
It would be 300.
So we've
It'd
got
be 6 times 5. I would say 300. Yeah.
60, 60, 60, 60, 60. Yeah, 300 degrees. So that's less than 60, right? And then we got the octahedron right here. On the octahedron, again, it's made of equilateral triangles, but we've got 4 equilateral triangles coming together. So how many degrees are coming together at this point?
240.
So 60 times 4, 240. Again, you can see that it's below 360 degrees. It's just a really interesting thing how the platonic solids can only be made in this way. Because each vertex has to be less than 360. Okay, so in section 11.4, you want to be familiar with your solids, be familiar with how to name a face, an edge, a vertex, and so on. Be familiar with Euler's formula that the number of vertices plus the number of faces minus the edges will equal 2 on any of the polyhedra. And remember, polyhedra are made of polygon faces. Know the difference between a pyramid and a prism. A pyramid comes to a point and a prism has parallel faces. Okay, then looking at number 17. Is each of the following a nut or a polyhedron? Could you fold those up to make a polyhedron? What do you think about A? Would that be folded?
Yes. Can you share your screen?
So I'm just going to hold up number 17.
Oh,
If you've got your book, look
okay.
at it. So this net, can that net be folded into a polyhedron?
Yeah.
Yeah.
Have polygon faces all the way around it.
Yes.
I would say,
Well,
no, it's missing that.
no.
No, it's missing one of the faces.
If it had one extra little pie, I think it could, right?
It's missing the base piece.
Y'all are so good.
It's like your tetrahedron, but the base is missing.
I wouldn't have thought that.
Yeah, so that one would not be. How about B? Could B be folded up?
Yes.
Yes.
Yeah, yes.
Rectangular prism.
I kind of disagree with that one because
Yeah.
the little shapes in the center of it, to me, those don't look like squares. They look like tiny little rectangles. The answer key says yes, it can be. But I disagree with that one. So on that one, I would accept either a yes or a no. It's just small, so hard to tell. I disagree with the answer key on a couple of several. So I'm just throwing that out there. That on 70, I thought it was no.
It can't be folded into shape.
Until a polyhedron.
Likewise, on 13B1, it was asking if you can make that blue square by like stamping that rectangular prism onto it. They said yes, and I don't think it can. I mean, I can see how on 2, the cube could be stamped onto that square. 3, the square pyramid could be stamped on it.
Oh, I agree with you because when I did my answers, I went and looked at the book and they had that one circled and I still didn't circle it when I turned my homework in.
Yeah, I just didn't think. Now, number 4, you're allowed to use the top, side, and bottom views. So at the top view from that octahedron it would be the square, but number 1, I disagree. It looks like a rectangular prism to me, and I don't think it's gonna.
Well,
Yeah,
now, the
but
only
it-
thing I was thinking of was because a square, and the only thing, like, isn't a square a special rectangle? And there was something to do with that. That's the only thing I thought maybe they were thinking outside of the box. But I'm like, that particular square cannot.
Yeah, not
in
that
any way,
particular
shape, or
square.
form. Right.
Which
Right.
one are y'all talking about?
This one.
13B.
Yeah, this one here.
13B gives a blue, yeah, if you can hold that up for everybody to see, it gives that shaded in square on
Like
the
this?
left. And then I is a rectangular prism. And even if you did a top view, a side view,
There's
a
no
big
way.
view, you're still not gonna be able to get that square that they give on B. So I think that one is a no on I.
Oh, you see, I didn't circle it. I just sent it in as I thought.
And then the last one that I disagreed with was number 2A. Has anybody else done 2A yet?
No.
Yes.
Or not A, 2B, sorry. 2B, you're supposed to give how many cubes are in the stack, which I agree with that. How many cubes? I saw there's 24 cubes. And this one, you might want to use that isometric drawing tool. Let me take you there again. I have it linked in the announcements, cube drawings tool. This is free, so share it with your schools. It's a great tool.
Yeah, I saw what they put, but I could not come up with that. With the 92 part of it.
The 92, I could not come up with the 92 either. Because it's asking how many faces are glued together.
We know 24 of them are taped together because they're on top of each other.
2.
So if we just tried to draw part of this on the isometric drawing tool, if I brought one cube in,
Because they're glued together.
And then let's say I put another cube next to it. If I wanted to look at how many faces are glued together, to me, it looks like in this drawing that I have for you here, there would be two faces glued together. You would have this one here and the one on the other side of this cube, and you put them together and you glue it. So there's two glued together, right?
Right.
Okay, so for part B, I looked at how you've got 8 cubes on each row. So I thought, okay, you've got 8 faces for the first row, 8 faces for the second row, and then you have to double it because you're getting glued together. So I saw 32 there. And then on the other rows, there was 6 each for a total of 18, and then doubling that. And then there's 12 looking at the top view, and doubling that is 24. So I got 124 for my total. Correct me if I'm wrong. I'm not putting that one on the test, but I did not agree with that answer of 92.
Dr. Knapp, this one really stumped me too, but I came up with, just bear with me, this is just how my brain works. If you look at the sides, all the way around, it's 20 blocks all the way around. And each one is glued to 3 sides. So 20 times 3 gave me 60. And then those 2 in the middle are glued on 4 sides. So 20 and 4, I mean, I'm sorry, the 4 in the middle gave me 8, right?
Yeah.
And they're glued on 4 sides, so that gave me 32. So 60 and 32 gave me 92 sides glued together.
Yeah.
A lot of figure this out for you.
We just figured it out. Yes, we did.
I
I
don't
think you're gonna
know.
do this tomorrow with Unifix cubes.
Yeah, my brain just works totally different. Probably explain all the gray hairs I have, but that's how I came up with it.
Well, thank you very much for helping us with that. Now, it's already 6:49. Time flies when you're having fun. I love this geometry. Hope you're starting to enjoy it too. But anyway, if you want to stick around and ask some questions, you are welcome to. Don't forget the 11-4A homework is due Saturday night. There's a discussion due Friday night and a lab due Sunday night. And then we are done with our first chapter, and the test will be a week from Saturday. The Unit 1 test will be on February 17th, it looks like. So thank you, everybody. I had a fun time playing with all of this with you all. Let me know if you have questions. Come to my office hour Thursday night if you would like additional help.
Thank you. Thanks so much.
Thank you.
Thank you.
Thank you.
Thank you.
And is there anybody sticking around that has individual questions that I can answer?